So this is the physics activity 3 part 2. For this activity, I'm supposed to find the spring constant of a spring. I don't have a spring, so instead I decided to use a ruler, which would act as a spring in this case. So what I used for this experiment was a calculator, tape measure, books, ruler, pen, tape, and paper. You could use either a 15 centimeter or a 30 centimeter ruler. In this case, I used a 15 centimeter ruler. So next thing that I did was I created a little plan on what I was going to do. So what I did was I was going to take some books, really thick, heavy books, and I was going to stack them on top of a ruler, and I was going to have another book that's underneath the ruler, and I was going to make sure that the certain part of the ruler that's exposed, when I push down on it, it would act as a spring, and I'd have a little projectile or like some small little item that I was going to use. In this case, I think I used like a little pill, and I was going to push down on it, and it was going to, whatever value that it was going to go up, I would then use these in order to find into the mechanical energy formula in order to find the constant. And so how I thought of this was that the energy of the spring is equal to the gravitational energy, and when you input these two formulas together and you kind of solve for it, you get the spring constant. So now moving on to the actual experiment, one thing to note that I figured out was that the ruler, the more of the ruler that's exposed or that it's extended, the more springier that it's going to be when you push down on it, and the less that's exposed, so like the if you push it back more on the book, the more stiff that it was going to be. And of course this was really going to affect the spring constant, so I had to make sure that the length that's going to be extended when the books are covering the ruler, it was going to stay the same and that it wouldn't move at all, because of course, as you can see here, I was testing it, you want to make sure that the K value is the same for all of the other experiments. So of course here what I did as a solution in order to make sure that the spring wouldn't move is that I taped it down and I put really heavy books on top. So now the next thing was that I measured the distance from the floor all the way up to the ruler where it is at equilibrium, and this would serve as the x0 value that I knew I'd use for future calculations. So this is the actual experiment. There's the pill, and as you can see, it launched all the way up. And now the next thing that I did was I made sure to record it so that afterwards I could look at the markings as to where approximately as how high the pill launched, and that would serve as the gravitational energy. So the next step that I had to do, of course, was to figure out the formula that I was going to have. So as I said before, in this experiment, I set the spring energy equal to the gravitational energy, and the spring energy's formula is half k change in x squared, and the gravitational energy formula is mgh. So when I set them equal to each other and I kind of simplified it by moving the variables around and solving for k, I got the final formula of k is equal to, the spring constant is equal to 2 mgh over the change in x squared. Now this was the value that I managed to find after, this is the equation that I was going to use, and the next step was simply to plug in the data, the values that I got from experimentally, and finally find the spring constant. Okay, so that's it for this video, and I'm going to include more details on the values that I was able to get, as well as a little bit more analysis in the actual assignment document as well.